Hello and welcome to another video. In this one, we're going to be covering what's new in Python 3.13. And if the 3.12 video is anything to measure, this is going to be a long one. So if you're an Etho fan, go get your snacks and let's jump into it. All right. I've tried to organize my thoughts on this, but most of this comes from the what's new in Python 3.13 doc. With some added flavor for some of the stuff that I was involved in. But I've kind of split this up into 7 sections. And I hate when videos do the like, oh, top 10 new things, stick around for number 1 at the end. No, we're just giving you the good stuff first, and there's other decent stuff sprinkled throughout. 7 sections we're planning to cover today are build/etc. improvements, interactive quality of life improvements, it's personal, things that are related to stuff that I am involved with, some micro optimizations, deprecations, typing things, and then finally there's just a grab bag of random things at the end. There's actually a pun there, but we'll get to it when we get to it. Anyway, let's start with build/etc. improvements. And the thing that I think most people are excited about in Python 3.13, yes, it's the removal of the GIL, the global interpreter lock. I've actually done 2 videos on this already, so I would recommend you check out both of these, but I'm going to quickly show you a little demo about why you would want to remove the GIL and what it does. One side effect of this that I'm going to mention beforehand is this is a new ABI, application binary interface. So any C extensions and otherwise will need to be recompiled for Python 3.13. And this is kind of just one of the many trade-offs needed in order to do this. But anyway, I wanted to show you a small example, and I forgot what I named it, so give me 1 sec while I find that. Yes, free-threaded-demo.py. And so this file actually comes from episode 355, so this video, not that one, but this one, where I talked about the difference in performance between something that is threaded versus multi-processed. I wrote a small bit of code with a little timing context manager, something that does some work. In this case, is just adding a number in a loop. And I showed the difference between thread pool executor and process pool executor. And actually, I'll show you that right now just to redo that demo in Python 3.12. So in Python 3.12, if we run this file, you'll see that each of the works on its own takes, well, some of them are really fast, some of them are really slow. Basically, there is only one process or only one interpreter that can be running pure Python code in a thread at once, despite there being 4 real threads. And so overall, this takes about 3 seconds. If I change that to from thread pool executor to process pool executor, it will spin up multiple processes, and those can all run concurrently. And so, dang it, what did I do? Oh. That's for a later demo. Anyway, process pool executor, it can run them all concurrently, and so they can all do whatever work they need to, but there's additional overhead in spinning up and spinning down the processes. If we change this back to thread pool executor, thread, and we run this in 3.13, note this is just vanilla 3.13. Out of the box, it doesn't have the GIL disabled. So it still has the GIL, if we don't have the double negative there. Threaded demo. You'll see this looks very similar to the 3.12 one. It is a little bit faster just because 3.13 is a little bit faster. If I have installed the no-GIL, or the free threaded version, there will be a Python 3.13t, and this has no GIL, and you'll see that it is faster when dealing with multi-threaded code. A whole bunch of work went into this, and yeah, I was not part of this at all, but you can check out my other videos where I talk more about this in detail. If you want to try this out on Ubuntu, you can add the Dead Snakes PPA. I did not actually link this. Dead Snakes PPA, which is a PPA that I maintain. Who is Dead Snakes and why should I trust them? It's me. But you can install Python 3.13 already from here. It's currently at release candidate 2. And zoom in so you can actually see this. View package details. And if you install the no-go package, or actually here it is. I know it probably should be called free-threaded, and someone's grumbly about that, but I named it before they decided on the free-threaded name because I wanted to get ahead of things. So anyway, you can install this and try it out today. I don't actually see this on the Python download, so I don't know that there's going to be an easy way to get this, even though it kind of defeats the purpose of introducing it. But I don't know, maybe Conda will take over something there. Anyway, you can install it using sudo apt install python 3.13 no go. Yeah. Anyway, I've already done that, so that's how I have Python 3.13t. Okay, so that's that. Next, I want to talk about the experimental JIT, J-I-T. Now, what is a JIT? A JIT is a just-in-time, or at least that's what it stands for. And the idea behind a JIT is it is a piece of the interpreter that finds hot code as you're running it and optimizes it on the fly. JITs are popular in a lot of other virtual machine languages. So, for instance, like V8, the JavaScript engine for Chrome, has a JIT, and it will speed up your code as it runs, basically using a variety of ideas and processes. PyPy, a Python interpreter written in Python, is popular because, or it has popularized a JIT because that's how PyPy is so fast at running pure Python code. The JVM has a JIT. Lots of other languages have JITs, and Python now has an experimental one that is disabled by default. It's using a apparently novel approach to JIT called copy and patch. I don't know the details. It's based on a really complicated paper that I didn't understand, but I hope to read it again and hopefully I'll understand it eventually. But apparently it's a novel approach to JITs that has a little bit lower overhead, and from some cursory testing, it purports to be about 2 to 9% faster on pure lib code, pure Python code. You can't really JIT, well, I mean, you can. You can't really JIT compiled extensions because the interpreter doesn't really see it anyway. And there's this diagram that explains kind of how it works. There are 2 different tiers of optimization, not to be confused with Python support tiers. There was a lot of confusion in this thread. But basically, there's kind of 2 levels of optimization. The first is taking the Python bytecode and specializing it into micro-ops. Basically, specialized bytecode that does a very specific thing versus the more generic, high-level, disassembled bytecode. If I have a video on the disassembly of Python, so if you want to search that, Python is compiled, I believe is the title. And then the second level of JIT, go away, silly screenshot thing, is to turn those micro-ops directly into machine code so that you can run native code a lot faster. That's kind of the general idea of a JIT, is to turn high-level things into machine code, because machine code go brr. Anyway, I don't have a demo for this. I could have compiled beforehand, but I felt like this 2 to 9% told better story than me trying to set up PyPerf anyway. Okay, cool. So those are kind of the build improvements. Next, we're going to talk about quality of life improvements. And the first of these is there is a brand new, there's a brand new REPL, read, what does the E stand for? I don't know, print something. Read eval print loop, that's what it is. And you'll notice out of the box, it has some colors to it. I actually find the colors to be a pretty poor choice on this terminal, but they're just the default colors. This REPL was actually adapted from the implementation in PyPy, which we talked about earlier. PyPy has its own REPL that is also implemented in Python. Part of the reason that it's implemented in Python is a lot of PyPy stuff is sped up more Python you write. And so the new REPL in Python 3.13 is also written in Python and adapted from the PyPy one, and has a bunch of cool features. One of them is, of course, the coloring. One that I think people are going to be more excited about than anything else is you can just type exit now. Whereas in 3.12, you would get the exit built-in class, or not built-in, but site repr thing here. Now you can just exit. It just works, which is kind of cool. One of the other thing that's really exciting about this new REPL is multi-line editing finally works well. So if you got hello world, and then oops, maybe I meant to call this foo instead of f, I can, you know, multi-line edit something, which is really cool. And there's also auto indent, which is cool. There's a bunch of fun stuff. Also, history works with multi-line editing. You don't have to like press up a bunch of times and get a bunch of lines one at a time. So much nicer than the old annoying REPL. And if for some reason you need to turn it off, you can use Python basic REPL equals 1 as an environment variable, and that'll give you the old one where exit is sad and we don't have nice one-line auto indenting. Can't price up here. Yeah, see, I don't have multi-line editing. I don't have multi-line history. It takes you back to the old one. But yeah, that's that. The next thing I want to talk about in quality of life is tracebacks are now colored. We have this little traceback example file here. Nothing really special here, just a bunch of functions that call each other and a division by 0 here. If we run this, Python 3.13 traceback example, you'll notice there's a bunch of colors now. Again, the purple feels like a poor choice, but I guess maybe it'll improve over time. But anyway, you can see now there's red and bold for function calls. We still have the same arrows. That was not new in this version. I think that was 3.11. But yeah, there's colors in the traceback now. Hooray! This is bolded also. So a little bit of ANSI colors. And of course, if this isn't going to a TTY, standard error? Yeah, if standard error is not going to a TTY, then of course it won't be colored. So yeah, colors, hooray. This next one I'm so happy about. It is so minor, but I have run into it so many times that I'm so excited for this next thing I'm going to show you. How many of you have used breakpoints in Python and put them either at the end of a block or context manager or function or just at the end of something? Previously, if you ran this example in, let's say, Python 3.12, the function that I was trying to debug or look at or poke at has already returned because my breakpoint was at the end of the function, which is really annoying because sometimes you actually wanted to look at the stuff above it and you just happen to put the breakpoint at the end. This is no longer the case in Python 3.13. We're now right at the breakpoint right before the return, so we can actually debug the stuff we want to. So good. Very minor, but so good. Cool. All right. And again, yeah, color tracebacks even when we do BDB quit, which is Q from PDB. All right, sweet. This next one is aimed at beginners, and I am so happy that this has a specialized error message. I actually think a little bit more can be done, but we'll talk about that in a bit. I have to move that random.py file back to demo this. So a very, very, very common mistake in Python, especially for beginners, is to name a script file the same as a standard library module. Maybe they were learning random and they wanted to import random and call random.randint, and so their instinct was, oh, I'll just, I'm working on random, I'll call my script random.py. And unfortunately, if you run this in 3.12, you get kind of a mysterious error message. Partially initialized well, I say mysterious, I actually made this error message. Well, no, not this version. The attribute error is not my version. The from import one is. But anyway, partially initialized module has no attribute, and the reason is because the import at the top of random.py, this actually imports itself. And so, yeah, there's no randint, and so it crashes. But in Python 3.13, this error message has improved and is purple and is hard to read. Sorry, YouTube. But it says, attribute error, module random has no attribute randint. Consider renaming the full path of the file since it has the same name as the standard library module named random, and the import system gives it precedence. So there's a nice long error message that explains to you exactly what's going on and exactly how to fix this problem so that you're not clobbering the standard library. This also has specialization for, oops, sorry, that was while I was trying things out. This also has specialization for third-party libraries, even if you don't have them installed, which is kind of fun. The way it works is if you make the same mistake, or oh, that's 312. If you make the same mistake, it'll mention basically the same thing as before, but it'll say if it has the same name as a third-party module you intended to import. So it just assumes that if the attribute is of a module that has the same name as the file name, that you've probably made a mistake and are probably clobbering something. It doesn't actually analyze the standard or the import system, which is kind of nice because that would be expensive or more expensive. So that is that. I think this feature is really, really good, and it's going to help a lot of beginners. But there is one shortcoming to this that I think can be improved, and maybe I'll write a patch for this because that circular import message that I showed you before, this is actually introduced first, and then I improved it later by adding support for from imports, because this was only for attribute errors here, and it wasn't handled for from imports. And surprise, surprise, for whatever reason, the specialized error message for this self-file clobbering import thing wasn't implemented for from imports. So they still get the old error message, but I think this can probably be improved and, you know, might land in Python 3.14 instead. All right, anyway, those are kind of the quality of life improvements, little interactive stuff and debugger and things. Now we're getting onto the section where it's personal. These are things that either I was involved with or I'm just very excited to tell you about. Oh yeah, I meant to show you this pirate bowl. Oops, skip that one. Okay, so the first one is about virtual environments and git ignores. I don't know how many times I have seen a virtual env checked into a repository. You know, I've made the mistake myself. I've checked in a virtual env myself. Virtual env actually implemented this feature a long time ago. Again, this was actually based on my idea as well, but if you make a virtual env based virtual env and you look inside venv, there's a git ignore file. And so this kind of prevented virtual env based virtual envs from being checked into a repository. And if we look at venv git ignore, it just contains star with a little comment. Cool, great, whatever. In Python 3.13, the venv module does the same thing. Hooray! If we look inside venv, there's a git ignore, and it basically has the same contents. And yeah, I actually can't see the thread because I'm not logged into Twitter, but I recommended this 4.5 years ago, and it has finally ended up in Python, which is really exciting. The reason it took so long is people were squabbling about supporting other version control systems, and I don't know if we should make a special case for Git, even though surveys have shown that 95+% of developers are using Git, and no one else is using Subversion and Mercurial. Sorry, Subversion and Mercurial. It's just the way things are. Cool. The next one is a little bit petty, but you know, sometimes we can be a little bit petty on this channel. It's about import lib resources. And if we look here, there are some functions that got deprecated. There was this big long thread that I was very unhappy about and voiced my displeasure with the deprecation of these, in my opinion, perfectly good APIs that I was one of the rather early adopters to, because import lib resources is so much better than package resources. And then the rug was pulled out for me in Python 3.9, and I was supposed to use this weird traversable pathlib library that I didn't like and was slower. And there's a big long thread showing off all of the, you know, a bunch of people being like, why remove these? It doesn't seem like it's that much pain to keep them around, even though there's a legacy interface. Blah, 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 blah. And, you know, I chimed in and showed like this was the minimal amount of code with minimal dependencies to support this. And my goodness, there's quite a lot of code to make this happen. But anyway, long story short, another core dev stepped in and was like, hey, we probably shouldn't remove these. They're not that bad. And, you know, we could have just added the one feature to these and been done with it. And saved a bunch of toil and pain in the community to have to migrate yet again from these APIs, because people had just migrated from package resources to these, and then surprise, surprise, they had to turn around and migrate to something else. But anyway, these are all back and will not be deprecated. Hooray. Apparently there's one that will be deprecated, but no plan to remove it. So import lib resources, boring APIs are here to stay. Hooray. This other next one is a little bit petty as well. This comes from itertools.batched, and this is actually brand new in Python 3.12. Import itertools.batched. No, import itertools. I do. Help itertools.batched. Itertools is not a package. Oh, that's cool. Batched now has a strict argument to it, which will require that all of the batches are exactly the same size, which was originally a criticism / confusion that I had with this, and everyone in my Python 3.12 video called it out as like, no, you're wrong, it should have variable length. Well, take that, commenters. There's a strict argument which now does what I said it should have done. Yeah, we're a little bit petty here. Okay, anyway, that's the end of the personal stuff. AKA I'm petty for 3 things. All right, now we're going to talk about some micro optimizations that happened in Python. And in order to demo this first one, I'm going to show you a command with PyDoc, which is, if you're not familiar with PyDoc, it shows documentation of modules and stuff, and you can find the file name, which I find really useful. This used to be at the top. I don't know why they moved it to the bottom. That's a whole different thing. It's been at the bottom for a long time though, so what's done is done. I got this long command, unfortunately. Pager equals false. Going to disable the pager so that we can actually time it. And in Python 3.12, we're going to call PyDoc on a very particular module. This was pulled out of the bug report for the fix that I'm going to show you in a sec. And you'll notice that PyDocking this particular module takes a real long time. The person in the report said it took 20+ seconds. I guess my computer's a little bit faster than theirs, but 4 seconds to PyDoc a module is nuts. If we look at this in 3.13, hooray, it's faster. TLDR, there were some optimizations to how PyDoc finds the class body of a class and how inspect.getSource works. And in order to do that, demo file? I don't. Oh, I do have a demo file. Yeah. In order to show that, I am going to show you first a little script here. This will be a second part of this, where I just have some classes C, D, and E. E is conditionally defined, and in fact, this branch is never taken, but this one is. And the method that's used to find the source for that, first we'll do Python 3.12, import inspect, and first line no. The function is called inspect.getSource, and you can pass it a module, code object, function, etc. And that's fist, first line no.c, and it'll find the code for that particular class or whatever. And so you can pass it this, and it sort of figures it out by finding the module and then trying to find the syntax in the right place. But it's also not very good at it. So when I look up E, it's going to give me the source for fake. And if we look at this demo file here, that's in the branch that should never retake it. So the heuristics that it uses to find this doesn't really understand conditional stuff, and it has to guess at where the source is. And guessing tends to be pretty slow, and that's actually why that PyDoc example from before is really slow, because it has to guess a whole bunch inside the file. And the particular test file that I was PyDocking, this test enum, has a lot of classes, and it takes a long time to find all of them. So how does this new micro optimization work? And the answer to that, first line no.py. The answer to that is the actual classes now have a new attribute on them, which labels the first line number of their code in the file. So if we look at d.firstLineNo and e.firstLineNo, and this is just part of the completion time Python, and so now classes will have this. Oh, I should also mention that this particular case with the true and false now gets fixed because it's not guessing anymore. It finds them directly. So inspect and first line no, and if we do inspect.getSource on first line no.e, you'll see that we get the actual notation, which is really nice. I know PyTest has to do this a bunch to find where the actual test functions are, and so this will this should actually speed up how PyTest works too in a couple of ways, which is kind of cool. But anyway, this tiny micro optimization to add literally just the line number when a class is defined to its class object and can make PyDoc way faster. All right, next micro optimization. I do have, yes, docstring example. Docstrings in Python traditionally preserve all of the white space inside them. So even though you probably think of this as all kind of against this left edge here, there's actually space characters here. And if we run this in Python 3.12-i, and we look at, what's it called, f? The function? I don't remember. Yeah. If you look at the docstring of f, you'll see that those white space characters are preserved here. And you actually had to use inspect.getDoc for it to dedent them properly and give you what a, like a documentation tool would want here, instead of deleting white space here. In Python 3.13, those white spaces are now removed. So we don't really need inspect.getDoc anymore. You can just access this directly. But the reason this was done is actually kind of silly. Apparently this saves a lot of disk space for PyC files because the doc strings are actually stored in the compiled module, and those extra space characters, I guess, add up. Apparently on a particular SQL Alchemy module, this saved the disk space by about 5%. Which, yeah, I guess, disks are cheap, but I think this is still a good change anyways, because I can't imagine you would ever actually want this leading white space when you're inspecting docstrings. Cool. Okay, the next micro optimization. I can't actually show the optimization, but I do have a little example here. Apparently classes now have a double under static attributes, which shows all of the kind of static analysis assigned attributes at parse time. So if we Python 3.13 static attributes example, interactive it, of course. We look at c.static attributes. There was an assignment to self.y and self.x in it, so now that's available here. Apparently this is used to make the dictionaries of classes more compact when instantiating them, and they're instantiated lazily. This is part of like a faster C Python stuff. And so now that it knows the probable set of keys for a class, it can make a more efficient dictionary, essentially. One thing that I noticed that's a little bit weird is they're not inherited. And this kind of makes sense, but I guess you would have to like iterate through the MRO to figure this out and do like class.static attributes for class in this. And apparently object does not have this. Attributes. Oh, put a backslash at the end there. Funky. Oh, and typo. Hasadder is not defined. Did you mean hasadder? Hastadder. Dang it. Why did that not work? Oh, because this needs double underscore. No? I'm just gonna copy and paste so that my demo works. Really? Oh, I did object. Here we go. Yeah, so you can probably, figure them out by doing it this way. I guess we could do for adder in class.static attributes, and then adder. So this could kind of give you the list of attributes, although you'd probably want to set, anyway, it's not important, but yeah, you have to traverse the method resolution order in order to find all of these. Seems kind of neat. I don't know that it'll actually be too useful because it's static analysis time. You would want to do this statically rather than having to actually get the live class object, but it was used for an optimization in faster C Python, so that's why it's there. Okay, cool. That's kind of the micro optimizations. Next, I want to talk about deprecations. A bunch of dead batteries. I say dead batteries because there's often the mantra that Python is a batteries included language, and that the standard library comes with a bunch of functionality for a bunch of stuff. A bunch of dead batteries were removed from the standard library. These have been deprecated for a while, and there were modules that basically no one was using or had like much better implementations on PyPI, and so they were unmaintained and removed or broken or otherwise. One module that's not actually part of the, well, kind of a dead battery, but was actually used a lot, an exceptional lot, is the library lib2to3 and the 2to3 tool. This has finally been deleted. If you're not familiar with the 2to3 tool, it is a concrete syntax tree, and it was used as a migration tool from Python 2 to Python 3. But it was also used by a lot of code formatters and refactoring tools. In fact, like Black, the popular formatter, was based on lib2to3. Actually, a fork of lib2to3 called blib2to3 that was Black's modification to it. But yeah, it was pretty monumental in code formatting stuff. So pour one out for lib2to3. It also had a lot of problems, though, because it was an alternative implementation of Python's parser. It had a lot of quirks and mismatches from the actual implementation of Python. This is actually kind of a criticism of a lot of third-party parsers of Python, in that they're not perfect. They're going to be slightly different than how Python parses stuff, and lib2to3 drifted significantly over time, especially when the peg parser was introduced, because lib2to3 was not peg parser. It couldn't represent some of the things that, like the match statement, for parenthesized with statements, are just impossible to represent in lib2to3 without a bunch of hacks. But it's gone now, so goodbye. But yeah, like, a lot of Rust parsers have this problem as well, which they're not the actual same syntax as what Python parses. My hope and plea is that one day we will get a concrete syntax tree in the standard library again. I don't think it'll ever happen. I had hopes that it would happen when the peg parser was introduced, but that was kind of scrapped. Not the peg parser, but the concrete syntax tree. It would make code formatters so much easier to write, and I don't think it'll ever happen, but we can sure hope. All right, so the next one is a very, very minor thing. I do have a file for this. But I feel like the deprecation for this was done wrong. And so this is something to look out for if you happen to have this in your code. Class method in Python 3.9 gained a behavior in that you could chain it with other decorators. And so you could build a class property by putting class method on top of property. And if we run this in Python 3.9, it calls this as a property in the class. It passes the class in, and you can make dynamic class property. In Python 3.8, this actually produces a really funny output. Bound method question mark of class main.c. This was before class method had this special behavior. But apparently this was deprecated because if you, Python 3.10 will work. Class method deprecation. If you call help on C, it accesses the class properties, which might have side effects or otherwise, just because of help. And apparently this was seen as enough of a problem that this behavior was removed. This behavior was deprecated in Python 3.11. However, it didn't actually get a deprecation warning. The code works fine. It didn't get a deprecation warning in 3.12, and it doesn't crash in 3.13. It just produces a different output. So I feel like this is going to trip up a lot of people, and the Python deprecation policy is supposed to say introduce deprecation warning and then remove later. And I don't know why it was skipped here. And I hope too many people don't get burned by this, because I mean, it's been around for what, five years now, since 3.9. So yeah, anyway, this was deprecated without a proper warning. So spooky, but hopefully it's not a problem. Okay, next we're talking about typing things, and I know, oh, grown more typing stuff in Python. Oh, don't want to see any more of this. Yeah, we're talking about typing next, and okay, yes, okay, yeah, this was actually the thing about static attributes. I didn't call out typing stuff. Okay, so there's actually not too many things this time. One of them I am really excited about. I'm actually so excited about this that I already did a video on it. And I forgot what the title was. Let me grab that real quick and I will show you the title of that video. It is this one, PEP 696 is a huge quality of life improvement. This is about type var defaults. And do I have an example here? I do have an example. Type var defaults. Basically, type variables can now have a default. If you're using the brand new funky syntax, it's done basically like default parameters. In this case, this is saying I have a type var t and I have a type var u, which defaults to t. Now, MyPy doesn't have support for this yet, but this is kind of like a silly example where basically you can make a type var default to something else, and that it sounds kind of boring on the surface, but I'm going to show you a really awesome example of this in a second, and that other video actually goes into details. I actually have to install Pyrite, which has support for this. MyPy doesn't have it yet, except for the specific ones I'll show you in a sec. But if I do Pyrite on it's node modules bin Pyrite on type var defaults, and I think I need Python version 3.13, otherwise it won't work. Yeah, and so it'll say here that type of C1 is C int, and type of C1 wat is C intster, and basically this is the type var u that defaulted to type var t. Now the cool thing that I wanted to show you is generators, and I guess async generators. Prior to this PEP, import generator. To type a generator, you would have to do generator int none. The none being the send type and the yield type. And now those default, so we can just do generator int. Oh, it's so good. I'm so happy about this. And it's extremely minor, but this is something that I'm really excited about. And if you're excited about this too, PyUpgrade is already able to rewrite this if you're using from future import annotations or generator. Yeah, no, where is it? Here we go. Yeah, if you're using Py 3.13 plus, or if you have future annotations. So PyUpgrade already got your back here. It also does it for async generator, which has similar. Okay, the next thing, I couldn't find a type checker that had actually implemented this yet. Sure, we'll use the same file. There is a new function in warnings. Oh, I have a demo for this. Yeah, I have a demo for this. Do I? Maybe I don't. Okay, well, we'll just make a demo for this then. Warnings has a new attribute called warnings.deprecated. Use foo instead. Def bar. I don't know, maybe bar passes along its keywords to foo. And sure. And if we define foo as, I don't know, x print call bar with 1. So warnings.deprecated is a decorator which allows you to deprecate a function a lot easier, and it handles all of the like stack frame stuff automatically for you, so you don't have to worry about that. And at runtime, 3.13, at runtime it'll produce a deprecation warning. Great, but the important part and reason that it's called out in the typing bits is this will actually produce, if type checkers will implement it, this will produce a warning in type checkers, and so you could potentially annotate things that are deprecated and then have your type checker help you out when you're accidentally using something deprecated that might be going away in the future. And so that's why it's in the typing section, but it's also useful just for deprecating functions in general. Because previously you had to, warnings.warn, deprecation warning, use foo instead, stack level equals 2. because stack level equals 1 or the default is broken, but you can see it off screen. But trust me, there's a 2 there. Anyway, I think this is a lot nicer. And so, yeah, if you're going to deprecate stuff, use this thing. The other one is the other 2 typing things that I'm going to call out are sort of minor. One is read only. This allows you to annotate particular keys of a type dict as read only. This can be helpful if you want to enforce immutability, but the main reason that this was added is to allow variants for type dicts, because type dicts by default are mutable, and so if you had something that is only cares about the immutability of a particular key, you couldn't pass in 2 different type dicts that fit that same interface. But now that you can mark things read only, variant stuff basically. Essentially kind of the same argument between sequence and list. Sequence allows you to take in any immutable sequence, whereas list, or mutable sequence only allows you to take a very particular and not what's the word? Heterogeneous. But anyway, this allows you to mark read-only keys in a type dict. That's it. The last thing is type is, and I'm actually probably going to make a separate video on type is because I think it's that important. Type is basically a better type guard. Type guard allows you to make user-defined narrowings, and I already did a video on type guard, I think. Type guard, yeah. So check out this video on type guard. But type is basically the same thing as type guard, except it is it allows you to narrow things in else branches as well, whereas type guard only allowed you to narrow things in the positive case. So in this particular case, so like this is a more complicated. I wish they would have shown a simpler one. Well, we'll just use this one. It's simpler if they would have said parent here, but basically is parent says that the type must be parent, and so based on this union, the only thing it could be is this child here, because child is subclass of parent. So that means inside this branch it is child, inside this branch it is not child. Whereas if this were type guard instead of type is, this else branch could also still be child. It didn't narrow in the else branch, which made it less useful. I found that when working with type guard, I would often have like 2 type guards for each union, like one that checked the positive, one that checked the negative, and then an else branch that was just raise assertion error unreachable. But type is generalizes this a lot better. And I think arguably type is probably should have been the thing that got implemented in the first place, and I don't really see much use for type guard anymore. But there was a lot of back and forth on whether it should narrow in the negative case, and I think at least from usage now, it's pretty obvious that this is a lot more useful than the behavior of type guard. But yeah, I'm excited about this. I'll probably make a separate video about this just to go over that, but I haven't done that yet. All right, we're done with typing. I know, everyone's like, oh, typing, grown. Now we get the random grab bag at the end, and I guess to start, we'll start with random. Random has a command line now, so you can pass it. Oh, right. I should have used a different module there. Random has a command line now. You can pass it positional arguments. It'll choose from them. You can pass it an integer, and it'll pick an integer. You can also pass it a float, and it'll pick a float up until that value. It also has long arguments if you want to be explicit, but yeah, there's a quick command line tool for doing random now. The next one I want to show is argparse as a way to deprecate options directly. Argparse deprecated option. Basically, you just pass deprecated equals true, and if you run that, you get 13 argparse. What was the old option? I think it was. Argparse will directly print out that you're using an old option, which is kind of nice. I've definitely done this manually before in a bunch of stuff, but it's nice to have it directly in the argument parsing library so you don't have to worry about this. Cool. Okay, so the next one is in the OS module. Python 3.13, import OS. There's a CPU count, which I don't think is new. Maybe it's new. If it's not new, there's a better version of this, which is, what is it called? Process CPU count. Now, in my case, they're the same, but what process CPU count does is it takes into account schedule affinity, fancy words for how many processes are allowed to be used by this process. This is often used by container scheduling runtimes such as Kubernetes or other similar things. To basically say, like, okay, you only have two CPUs, you have 8, you have however many more on machines that might have like hundreds of them. Instead of like traditional CPU count where a container would see hundreds of CPUs and be like, great, I'm going to use them all, even if it might have only been allotted like 1 or 2. So I'm glad this function exists. A lot of the standard library was also changed for its defaults to use this. So for instance, I want to say multiprocessing's pool used to default to the processor count. Now it defaults to process CPU count, and so it acts better in containerized runtimes. So this is a great change and makes this much. Next one is also a very simple one that we can just knock out real quick. Types.simple namespace was a way to just make an object that has attributes and is really easy to make from keyword arguments. This isn't new. This has been around for a long time. But now types.simple namespace can take mappings as a single positional argument. So there's an easy way to convert a dictionary into a object. Now, granted, you could have just done this with Splat before, but now it supports mappings directly, which is a tiny quality of life thing. The last thing that I want to call out is copy.replace. This one is pretty minor. I don't know why it's at the end, but that's the way things go. Copy.replace. And there are a lot of objects in Python that have their own replace functionality. So for instance, datetimes. Datetime.now. So we have a datetime and we do now.replace year equals 2025. It's going to give us a new year where we've replaced out a particular value. Name tuples have this as well. So from typing, we'll do it from collections. Collections int equals collections dot. Yeah, it's been so long since I've made a non-typed one. Name tuple? Named tuple? I don't even know now. It's been so long. It's named tuple. Of course, it's named tuple. How could I forget? Name tuple also has this, but name tuples is underscore replace b equals 3. And this is done to avoid potentially clobbering the user's attribute names. Anyway, all this to say is there's a bunch of things in Python that have this sort of replace functionality. Basically, take an object and produce a new object with some attributes changed. This has now been generalized as double under replace. So if we call our particular name tuple .double under replace b equals 3, that gives us a new name tuple. And copy.replace uses that protocol to actually do that. So if we do copy.replace with object2 and b equals 3, we get a new one here. I actually don't really see much value in this because I feel like if you're dealing with an object that you already know has this replace protocol, you're probably not worrying about the getting a duck typed version of something like this. So I'm not really sure why this function exists, but maybe time will tell and I'll eat my words on that one. But I do think standardizing on double under replace is really nice here because this gives a standard way to implement the same functionality for your own classes. So if you implement this, you can take advantage of copy.replace, or you just generally get this behavior, which is nice. All right, that has been not my longest video, but quite a long video going into what I think is cool in Python 3.13. There's a bunch more other things in the changelog that I didn't call out, but you can run through those yourselves. I did want to mention syntax changes. There is only one syntax change in Python 3.13 that I know of, or at least that the docs seem to call out, and that is in this type var defaults. This required new syntax, and so that's our new syntax. Anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.